Today on Plain Simple, part 2 of air conditioning in aircrafts, the air cycle machine. Hello everybody, welcome back to Plain Simple. Like it says on the video title, this is part 2, or the second video related to air conditioning systems in aircrafts. Part 1 was related to the more traditional style of air conditioning regarding that uses Freon or whatever refrigerant. It's a closed loop system used the same as in cars and buses and houses. Those are used on smaller aircraft, so you can go back and see that part 1 if you haven't seen it. If you've already seen it, welcome to part 2. This one is gonna relate to a completely different system, different operating principles, but still the same function: to carry heat away from the aircraft interior to condition the air, to cool the air and carry moisture away from the cabin. And this second system uses what's called an air cycle machine. The air cycle machine, this whole system, this air conditioning system, is an open loop, in the sense that in the previous system that we looked at in part 1, it was a closed loop system because it recycles the refrigerant over and over and over, using the same refrigerant to carry heat from one side to the other, from inside to outside, or whichever direction you want. In an open loop system like the air cycle machine, you don't have that. Air is your cooling medium, is your refrigerant, and is also the fluid that you're pumping into the cabin. And in this video we're going to look at how this works. And I promise we're going to get to the aircraft. We're going to look at this whole system in the aircraft. We're going to look at an actual example of this very same setup here. But for now, we'll start with the theory, so that you can make sense, so that you can understand how it works. Then we're going to look at this very same setup in an aircraft. But I want to go through all this theory first, so that you can recognize all these components. When we go to the aircraft, you'll understand what it is that I'm pointing at, and you'll be able to make sense of what it is you're looking at on the video. So we'll start with the theory. First, we'll follow the path of the air as it comes in. This whole system, this is two mirror images, because most aircraft that have this type of system have two packs, two air packs. And packs is P-A-C-K. That stands for pneumatic air conditioning kit. P-A-C-K, or pack, and they're referred to as the right pack and left pack. The air, outside ambient air would come in through here, through ram air. And just so you know what this ram air and where this is in the aircraft, this is a view. It shows you the back of the airplane. Here's the left engine, right engine would be over here, and inside of here, this cone here is right in front of the rudder, and it is literally an opening, a scoop, an air scoop, to get air, ram air, picked up through there and routed into the left pack and the right pack, and splits through this white duct here, supplying ram air into the packs, right pack, left pack. So this ram air is, and the Y split like that is what you're looking at in schematic form here. Here's that scoop, ram air coming in, splitting into the Y duct, into the left pack and the right pack. Now, since both of these are mirror images, they're both identical, I'm only going to explain all these things on one. The other one is exactly the same. So we start with ambient air, ram air coming in from the outside and going through this heat exchanger, and this air that comes in here is what does your cooling, and it gets exhausted out the back of the airplane. That ram air comes in through here, goes through the heat exchangers, and it gets exhausted out the back of the airplane, as taking heat away with it. So ambient air comes in and does your cooling, carries heat away from the heat exchangers, and it gets dumped overboard. The same air plus heat taken away from the heat exchangers here. Now, and that would be the case of air being your refrigerant. That this outside air is what's taking the heat away from your packs and dumping it overboard. Now, the air that actually gets pumped into the cabin is coming from the engines or the APU, the auxiliary power unit. This air is bleed air. Bleed air is air that bled off of the compressors of the engines or from the APU. This hot compressed air comes in through here, and it comes through the primary heat exchanger. Now, primary because it is the first heat exchanger that bleed air encounters. This would be the first heat exchanger, therefore the primary heat exchanger, where it dumps off. It is cooled off. This hot compressed air is cooled off, and that heat is carried out and dumped overboard. So now you start with compressed, high pressure bleed air that's been cooled off, and you run it through the compressor of the cycle machine. This compressor is a centrifugal compressor. This assembly here in the air cycle machine is very, very much like a turbocharger, where you have a turbine, you have a compressor. The compressor compresses this bleed air that's been cooled off. It compresses it, and it raises the pressure and its temperature one more time. And it goes through the main heat exchanger. The main heat exchanger, in this case, would be the secondary heat exchanger, because it is the second heat exchanger that this bleed air encounters. Here's a primary, it gets through the compressor and comes to the secondary or main heat exchanger, where again, heat is taken away from your bleed air and dumped overboard, carried out by your ram air, ambient air, and dumped overboard. So this is the second time that you're cooling off bleed air. From there, it goes through what's called a water separator loop, or water extraction loop, or a high pressure water separator loop. Loop in the sense that it comes around and does a full lap around here through dual heat exchangers here. It does a full lap. There's a water separator. The way it separates the water from there is once it's cooled off, it runs through here, and this heat exchanger here is cooled by the output of the turbine. This turbine is what gives the final cooling, expansion and cooling of your air. And this is the lowest temperature you see in the whole system here. Once it goes through there, it gets pumped into the cabin as air-conditioned cool air. But in this heat exchanger, which sees the cool air output from the turbine, from the air cycle machine, is where you're piping your bleed air through here, and you're cooling it off here to condense, to force the water, whatever moisture was in the air. Remember, the air coming from here is ambient air that went through the engine's compressor, not combustors, not fuel. You don't see any fuel or any combustion in that. This is air from the compressors. So it's ambient air that gets compressed, and it gets piped into here as bleed air. So whatever moisture content was in the air is still present through all this, and you cool it off here to condense the water out of the air. Once the water condenses out of the air, it gets collected in the water extractor, the water separator, water extractor. From there, the now drier air, all the water staying here, getting collected here and separated and drained out. Now the drier air comes back and it's piped into the turbine of the air cycle machine, where it is allowed to expand, and therefore it loses pressure and temperature. This is bringing the air-conditioned air to its coldest temperature here. And from there, going through this again, heat exchanger here, to cool this air, charge of air coming in, to condense the water out of it. It goes through there and then gets piped into the cabin, where it goes to a mix manifold, where it gets mixed with hot air, so that you can manually select from the cockpit or the cabin whatever temperature you want. Because you can get freezing temperatures out of here. You don't want to freeze your passengers, you don't want to freeze yourself. So down here in the mix manifold, you mix to whatever ratio you want hot bleed air with cool air-conditioned air from here. That happens downstream here before going into the cabin. That is how the air cycle machine works. You're starting with hot compressed air and you cool it off from your ram air. Cool it off with your ram air. Once you cool it off, you compress it again, elevate its pressure where it gets hot, and then you cool it off again. So now you have cooled, high pressure compressed air. Separate the water out of it to prevent ice from blocking passages and forming downstream of here. So you take the water out of the air. Now you allow it to expand where it cools off to actually below freezing, and then you pump it into the cabin and select where you mix it with hot air and you select whatever temperature you want. In the case, granted, you only have ram air here when the aircraft is in the air, when the aircraft is flying fast enough. But you can still run this system and get air conditioning with the aircraft parked on the ground. Where's your ram air coming from to do your cooling? If the aircraft is not moving, when you don't have ram air. That is why you have this fan here. On the same shaft, on the same coming shaft as the turbine and the compressor for the air cycle machine, you have a fan. And this fan takes over on the ground whenever there's no ram air to do your cooling. This fan takes over and moves and pushes air out, and it draws air in from the ram air ducts to provide cooling. So on the ground, when there's no ram air, this fan will provide the airflow to do the cooling on your heat exchangers here. Now, this is very easy schematic, easy to follow schematic. This is a little more convoluted, a little more difficult to understand. So you have ram air coming in through here and coming to the top of the heat exchangers here. So you have ram air coming down through here and being exhausted out the back over here. So it comes in from ram air, comes in through here, gets split, goes through the heat exchangers, and it gets exhausted out the back of the airplane. On this side over here, this is the same thing. This is the complete pack. Remember, pack is pneumatic air conditioning kit. You have ram air coming in through here, through your heat exchangers, and getting exhausted out the back over here. Your bleed air is coming in through here. Bleed air from the engines or the APU is coming in through here to the center of this primary heat exchanger. From there it gets cooled, and again that heat gets dumped overboard with ram air. From there it goes into the inlet of the air cycle machine compressor. This here is the air cycle machine. Here's the inlet to the compressor where it gets compressed, and it gets piped through here back to the main heat exchanger, which is these two. It goes in through here, up and out, back through here. So again, this is the compressor outlet, comes into here, into that heat exchanger, up here and back out through here. So it goes through 2 floors of heat exchanging here, again being cooled off by ram air flowing through here and taking all that heat out and dumping it overboard out the back of the airplane. Now the cooled, compressed bleed air comes to these two heat exchangers, and that's what we looked at here. Air comes in, the primary from bleed air comes from the engine or the APU through the primary heat exchanger, through the compressor, back in and out through these dual heat exchangers, and back to these two heat exchangers, which this here forms your water extractor loop. Here's that same path. Bleed air comes in through the primary heat exchanger, goes through the compressor, back through 2 floors of heat exchangers here, where it gets cooled even more, and then it goes to right here. Comes down through here, and on this particular view you can't see it because it goes out the back through the water separator, which would be on the far side of this. You can't see it here. And from there it goes down, out, and back in through a pipe that's back here, comes back in. So this comes down through here and then goes back out and gets piped back up through here, back through this heat exchanger, and it comes into the inlet of the turbine. This would be the inlet of the turbine. This is the turbine here. In the turbine here, this is where the air is allowed to expand and get to its coldest temperature, where it again goes back through here and to the cabin. To the cabin through these ducts over here, discharge ducts. Left pack discharge duct and the right pack discharge duct into the cabin, or into the mixed manifold where it gets mixed to select whatever temperature you want. Now this here is what we're going to look at in the airplane. We're going to go look at that now. I just wanted to explain all this to you so that it makes more sense now when we go see it in the airplane. All right. Meet me over in the airplane. I'll wait for you guys there. Wait. Something else that I wanted to mention, which I'll show you in the airplane. The water, which I think is pretty cool. The water that gets collected, separated from the air here, it gets piped over to and sprayed on top of the heat exchangers to increase the thermal efficiency of these heat exchangers, because now you have a water mist, a water spray being sprayed onto them. And the water is the very same water that gets drawn out of the air that's used here and then dumped overboard. But I think it's brilliant that it gets used over here to further increase the efficiency of these heat exchangers. And I'll show you that pipe in the airplane. You'll see it coming from the water separator to this planet to the ram air ducts right above the heat exchangers. Alright, meet me in the airplane. Hello, welcome back. Thank you for meeting me in the aircraft. We are now inside of the tail of the aircraft. We're in the tail cone, or just before the tail cone. In the diagrams and the pictures you saw before, you know where we are in the aircraft. This is, right now I'm facing aft, in the aft equipment bay. That means that the tail of the airplane is back there, the nose is behind me. Way behind me. Right here we have the left pack, and here's the right pack. Two identical units, and this is what we looked at before in schematic form. Now we're looking at the reality of it. Starting from the top, we have the inlet of ram air. The ram air scoop is somewhere up there. That's the top of the fuselage. And it comes down and splits into through that Y into the left pack and the right pack. And as we saw in the diagram before, the air goes through the heat exchangers and it gets dumped overboard out the back of the airplane. And we're going to take a look back there now in a couple of minutes. Actually, no, let's start over there. Since the flow of air through this whole machine the air cycle machine starts from back there. Let's climb up there and take a look at where the air from the APU or the engine's compressor bleed air. Let's look at where the bleed air comes into these units. Let's go back there now. Okay, I climbed in a little further now. This is the heat exchangers on the left, on the right, heat exchangers on the left. And remember, I'm looking aft now, and right and left is always aircraft right and aircraft left. And aircraft forward, the point of reference is always in reference to the aircraft. So, although I am looking to my left, this would be the aircraft's right. So this is the right pack. This is the left pack. And now looking further back, we see here that is the inlet of bleed air with a control valve. Bleed air from the engines or the APU. Bleed air coming into the primary heat exchanger, which is the one on the bottom over here. Primary again, because that is the first heat exchanger that bleed air sees. Here's the one on the other side. Bleed air coming in to the heat exchanger. And that pipe right below that, that is taking the ram air that comes from up there, goes through the heat exchangers, and it takes heat away from here and exhausts it out the back of the airplane. Same thing here. Bleed air comes in, ram air comes in, cools off, and bleed air, and takes that heat and dumps it overboard. That's where that happens. Now, looking at the rest of this is you had bleed air coming in through here, getting cooled off in the primary heat exchanger, going into the inlet of the air cycle machine compressor. There's the inlet, and it swirls it around, compresses it, shoots it up here, through there, basically from there, into the main heat exchanger. Just like we saw in the pictures before. From there, it comes through here to these two heat exchangers. Where it gets, let me take a step back to make it a little easier to film. Okay, this is where we left off, leaving after bleed air comes in, gets cooled off, goes in, gets compressed, gets fed back in, goes through the heat exchangers, dual heat exchangers, and it comes over here, where it goes through those heat exchangers, gets cooled off by the turbine's turbine cool air here to condense the water out of the air, and the water separators on the far side of this. But lucky for us, we have a copy of the machine over here, so we get to see the other side. There's the air coming in from the heat exchangers, going through these heat exchangers here, where it gets cooled by the turbine's exhaust. Here, this is the coldest you're ever going to see. The water gets condensed and separated out of here, and see that green pipe over there? That is a drain from the bottom of this, taking that water through here and taking it up there to spray the water on right into the path of the ram air, and now you have a mist of water being sprayed over the heat exchangers. So the same water that gets extracted from the bleed air gets collected and piped to that sprayer. After that, after the air goes through these heat exchangers, it dried up, it comes back through here. So once we come back over here, now it puts us on this side, which we can see over here. And now it gets piped into the inlet of the turbine. So up to here, we have bleed air that was cooled off, compressed, cooled off again, then brought over here to drain, to cool it even more, to drain the moisture out of it. The water gets collected, it gets sprayed over there, and then dumped out the back. Now that air that's already dried, but still high pressure, comes in through here, and it gets expanded in the turbine. And that air going through there, spinning the turbine, is what spins this compressor, which also spins that fan, which lives inside of the plenum here. The plenum is this housing here. The fan that takes over to create the airflow in case there's no ram air coming in, that fan is powered on the same shaft as the compressor on the turbine. It's powered by that turbine. And what powers the turbine is the bleed air from the compressor. So there's bleed air, high pressure coming in, powering all this, spinning the turbine. But here the air gets expanded. Its pressure drops, and so does its temperature. That's why here, at the exhaust of that, the outlet, it's not exhaust, it's the outlet of that the turbine, that's where you have the coolest temperatures. And it goes through here. Again, this is the same heat exchanger that extracted the water out of the air, and it gets pumped through there into the cabin. Now I'm looking forward. This is a pressure bulkhead. From there forward, it's sealed, pressurized cabin forward of this. Where I'm standing at now is not pressurized. And these are the discharge ducts. From the left pack, discharge duct, right pack, discharge duct. Getting pumped into the cabin, into a mixed manifold where you select your temperature. There you go. Now you have seen the theory of air conditioning, two different systems used in aircrafts. You've seen the theory of refrigerant closed loop air conditioning. You've seen the theory of an air cycle machine, how it works, the theory behind it, and now you've seen an actual air cycle machine. Not one, but two. Most aircraft usually do have two, minimum of two. Here. Thank you for joining me. Thank you for coming along. I hope you find all these things cool. I hope this was useful. I hope I'm not missing anything. And if I am, you guys will let me know in the comments. And anybody else who's a little more familiar, again, I'm not an expert on any of this. I'm just a fan, an enthusiast. So if anybody else wants to add to the knowledge base of these videos, of the people reading the comments, you're more than welcome to. That is always welcome. There's always people out there that know more than me, which is not hard to do. Alright, enough chit chat. Thank you guys again. See you next time.